Today we are going to discuss on the topic process control block diagram. Once we complete the discussion on this topic, you should be able to classify the elements of the process control loop into various blocks mentioned in the process control block diagram as shown in the slide. Let us consider a simple process that regularly we observe in our home. That is cooking of rice, that is boiled rice, making boiled rice from raw rice. Your mother is going to make boiled rice. How she is going to do it? She is going to take raw rice, put some water, put those things in a pressure cooker, and then she is going to keep it on the flame. So how this process happens, when the boiled rice is going to get ready, that depends on various techniques. That is, a measurement is to be done and a control action is to be taken. What your mother do? She will keep the things on the flame, the pressure cooker on the flame, and she will wait for the whistles to happen with your pressure cooker. So once the whistles are going to start, she will start counting the number of whistles where she is calculating. So normally what happens is, whenever you keep a pressure cooker, depending upon what you are going to cook and what is the strategy you have followed, you may wait for 4 whistles, 3 whistles, 5 whistles. So what happens is, once the whistles are going to start, then you are going to do measurement. So first whistle, 1, 2, 3, like that, and you are going to also compare, that is error detector, whether it is of 5 whistles. If you are going to set for 5 whistles, then 5 whistles are over or not, she is going to compare. That is a error detector. Once 5 whistles are over, your controller, that is the brain, is going to inform that yes, this job is done. She is going to use her hand and the fingers to switch off the flame. Process is making rice in your home, and she is going to control the operation, where her brain acts as a controller as well as an error detector, and she is hearing the sound through ears. Ears are acting as sensors, and measurement will be done. And once the measurement is done and error is detected, until the error goes to 0, she will not take any action. Once error becomes 0, that is the number of whistles is equal to the count value, she is going to switch off the flame by using her hand. Hand is acting as an actuator, and the fingers are acting as the final control element. This hand, that is the actuator plus final control element, is the final control operation that we have shown in our block diagram. So now let us take an engineering example. So this is a flow control system where the flow of the fluid in the pipe is to be controlled. So we are having a measuring system here. Already you have discussed some flow measurement techniques in your process instrumentation. We are having orifice, venturi, these things can be used for measurement of flow. So we are having a pressure measuring system here, and that flow will be measured, the flow rate will be measured and will be converted into pressure. So this pressure signal will be transmitted and it will be given to a controller as shown, and the controller will measure the value of flow rate through the pipe, and it will send a signal to the actuator, which is a valve, which is a pneumatic actuator, and the final control element will act on the process to vary the flow rate. This is one engineering example. We can have several engineering examples like this. So when I give you an example, you should be able to classify the elements as measurement. Here, this flow sensing device, that is orifice, plus this pressure converter acts as measurement. This controller will act as an error detector as well as controller, and this valve will act as an actuator and final control element. Okay, thank you.